My name is Divya. I'm here to present my ETL technical project. So the data I use for this project is from um, official government of Nova Scotia Tourism's website. It is an open source data. OBS Studio is used to record this presentation, and the IDEs I'm going to use are Visual Studio, where SQL Server Integration Services is configured, and on top of that, SQL Server Management Studio. Let's start. Here, let's talk about connection managers first. So I have um, two raw data in this case. So I have two source data. One is tourism of Scotia and the other one is operator types. And I have a target database. This is the um, native OLEDB driver connection that is connected to the database name. And I do have um, two error files. These are the same as the source files. I just added corrupt data to capture the error log. By doing this, whatever errors are coming up from the source data will successfully be captured into an error table instead of failing the whole ETL process. We'll talk about this when we are at that stage. For now, let's start talking about the staging table. Here I have two staging containers. In this case, let's talk about one, and the other one is going to be the same functionality and same set of rules. Now, staging tables is the place where we are extracting, cleaning, and validating and standardizing the data. After this point, we expect the data to be a bit clean so we can do further division and organization of these into dimensions and facts. So here in my tourism Nova Scotia staging, initially, let's talk about the data flow first. Within the data flow, this is my connection, which is a OLEDB source, which is a flat file here. So my flat file is passing through a data conversion. This is just to avoid if there are any conversion errors down the lane. So I have a data conversion here, and the converted data is loading into a staging table from Tourism Nova Scotia database. So like I mentioned earlier, there is an error log file. So if there is any error, and that error rows will be captured into our error table, which is in the database. So under add annotation, I just gave the details for stage table and error table. This is just for reference in future. If someone is coming and looking for the code, they have it here. But when we execute this, it's not going to affect our process. Let's talk about the dimensions tier now. So here I have two execute tasks for dropping the index. Please ignore those for now. This is strictly technical presentation. When we come to the reporting part of this data, we'll talk more about these. Coming to dimensions again. So the data collected into my staging tables will be sorted and arranged into corresponding dimensions. In this case, here I'm talking about mode of entry. So the OLEDB source here, I'm using it as an SQL query. So from my staging table, I'm collecting the relevant data that is in terms of mode of entry, and I'm passing that through the lookups. These lookups are maintained to make sure the data is not being duplicated and only the data that is not already available in your dim table or the dimension table will be loaded. So that's the condition we set up here. We set up as no match output. And my dimension is a table that is in the tourism Nova Scotia database, and I have my mappings done here. Just like in staging, everywhere there is a new table created, I have added the DDL here for future references. Let me show you how flexible it can be when we create these using our SQL queries. In this case, let's look into the timelines dimension. Now, similar way, I have a OLEDB source, which will be an SQL command, and I have a lookup to pass only the no match output, and I have my dimension table. This is the corresponding detail. Now, in this query, um, so all I'm taking here is one column which came from the source data, that is mostly it's essentially a datetime field, but using that field I have segregated it to year, month, and then I've arranged the month number and the month name. Similarly, based on the month, I have created a column using case statement for seasons as well. So in my case, it'll help me a lot if I could analyze tourism data based on the seasons as well. So that's the reason I have created an extra column from the date time. Now, this seasons will be used for our reporting purpose. Coming to the facts tier, fact tables are the places where the metrics and transactional data are mainly stored. And in our dimensions, we'll have a primary key or a unique key, but in the fact tables, we are joining these dimensions using the foreign keys. So when we look into SQL Server Management Studio, I'll show you how the tables are connected. For now, beyond this, I have again a reporting container. We are not looking into that right now. So if I want to execute the task here, I just need to press start, and one by one, all the tasks will be completed successfully. Just to double check, let me execute it 2 times in a row. That's the second time. It's all completed successfully. Now, I have already deployed this package into SQL Server Management Studio. So I can run this package either from here or from Management Studio as well. Let me show you that. The basic idea behind this exercise is we have a source file which may or may not have some um, erroneous data. So the idea is to import the source file into a staging table, handle the cleaning and necessary checks from here, and after that, the staging tables will be loading data into dimension tables, and from dimension tables through the foreign keys connected, the data will be loaded into the fact table. So on top of this, the only extra thing we have is truncating the staging table and the fact table. This is just to clear any earlier data that is not available or not coming from the next source file. In case the source file has changed, truncating the table will help us maintain or stay in sync with the current source file. We are not truncating dimensions, so whatever dimensions have already been created will remain. On top of that, from the new source file, if there is a potential for a new dimension, for example, in this case, I have a mode of entry dimension. Right now, based on the data we just have air and road mode of entry. Say in future, there is a waterway that is open to Nova Scotia. So we might have tourists coming through cruise or, so there is a potential for a new dimension there, which could be water. So in case in that, if that happens from the new source file, we will still have air and road from earlier, and water will be added to this. So that's being handled there. And again, from the fact as well, we are just truncating to keep in sync with our source file. Now let's look into SSMS and then see how all this works. Here in my SSMS, so Tourism Nova Scotia is the database that I have created for this project. So I'm running use Tourism Nova Scotia to stay in context here. Now, to show that the ETL process is performing without error, I'm going to truncate both my fact tables here. So that's the truncate. And I'm selecting everything from these two fact tables to check and show that there's no data in these fact tables now as we just truncated it, right? So like I said, I have deployed the package already. So I have SSISDB and my tourism Nova Scotia deployed here. So the same way I can execute my package from here as well. I'm executing and notice my execution ID is 71 here. Let me do the second time. That is 72. Now, this is the all executions report that comes from tourism Nova Scotia. If I go here, reports and all executions. So I have just loaded it because sometimes it takes a few seconds. I have just done two executions, that's 71 and 72. So these two are completed successfully. And if we want to see the step-by-step execution, that's overview. When we click on overview, so this is tourism Nova Scotia website and, package. It is each task, you see, dim operators, mode of entry, all the dims and facts are like getting executed one after the other. Now, we have executed successfully. So the original files have 7182 rows from fact tourism and 2521 rows from operator type. Now let's see. I'm selecting select star from fact tourism and 7182. These are the rows. And the second one, operator type 2521. So we have our source data loading into fact successfully. When I run my fact tourism with all the joins successful, there's our result. And similarly, operator type with all the joins. That's it. Now, I mentioned earlier regarding the error reports. So I have just modified the source file entering erroneous data. So it's basic data type mismatch or special characters errors, nothing outside the scope. So here, in this case, this is the count of tourists. So a number or integer is expected here, and I just force it to be a string in multiple um, ways. So I have introduced a single quote here, and I have introduced a text here, which will force the system to read this column as a string instead of an integer. And since that is happening, an integer is expected at a string place, these rows are being collected in the error log, but the ETL process has completed successfully. Similarly, for the operator type, so I have a latitude and a longitude column here. So just to trigger the error, I have entered some special characters or I have entered strings again. So that's about the error tables. Finally, I want to show how the relationships are managed here. Let's go to database diagram and try to create a new diagram. So since we have two facts, I'm adding the tourism Nova Scotia fact and the operator type fact. I'm closing this here. Since both my facts are here, I'm just going to right click and ask add related tables. So if our joins are all successfully completed, and if I say arrange tables, the tables are supposed to be arranged by itself. So this shows that our joins are done perfectly. So this brings me to the end of the presentation. Thank you very much for your time and attention. Take care.